Hello, this is Mr. Stansbury. I'm going to take you through the 14J assignment. All right, so let's start with number 1. On separate Venn diagrams, using two events A and B that intersect, shade the region representing inside of A. Okay, so let's do that. Okay, so if we're going to shade in just part A, then that's going to be this piece right in here. So that's going to be all this stuff right there. Okay. All right. B. Let's do that here. Uh-oh, wrong color. Okay, so let's do B here. So here's we're doing number B here. Sorry. So we've got the part that's just in B would then just be this area right in here. Right? So everything inside of B, including a little bit of overlap into A. All right. C. If we're talking about C, it's got to be in. It says it's got to be in both A and B. So that's going to be just this middle section in here. Okay. So this is what's in B and A. Okay. D is going to be in A or B. So if we're looking for that, that's anything. Oops, let's go back to red. I like the red. So that means anything inside of A, which is this A, or B. So it's everything inside of B as well. Okay. So it's going to be both of those regions all shaded. Okay. E is in B but not in A. So in B but not in A. So this part's in B right in here. Right in here. And then, but it can't be in A, so it can't actually include that middle piece. So we're just going to keep it just in this section right in here. That's all the part that's in B but not in A. Okay. And then F is in exactly one of A or B. So if it's in A or B, that means that it can't be in both. So it can't be this here, but it can be over here in A. Oops. Gotta make sure I don't get that crossover section in there, the middle piece. So it can be in A or it can be in B, right? But it can't be in both. So it can't be that middle section. So it's just these two sections out here. Okay? Okay, let's take a look at the next problem here. Okay, we've got the Venn diagram alongside illustrates the number of students in a particular class who study chemistry and history. Determine the number of students in the class total. So that is just going to be adding all these numbers up. So there's 5 people that are just in chemistry. There's 17 that are in chemistry and history. There's 4 that are in just history, and there's 3 that are in none of the above. So it's the 3 and 17 is 25. That's 29. Okay. B. Determine the number of students who study both subjects. So that's going to be just that middle section there, because this group studies chemistry and history. Okay. Part C. How many people study at least one of the subjects? So at least one would be 1 or more. So that's going to be our 5 plus our 17 plus our 4. Right? So that's going to be 26 total that study at least one of the subjects. Or you could do 29 minus the 3 that don't study any. And then D, the people who study only chemistry would be just these 5 right here. Okay? Now, just to help clarify on this here, if you were asked how many people study chemistry altogether, that would be 5 plus 17. That would be 22. The people that study history would be 4 plus 17. That would be 21. Okay, they didn't ask that, but they will eventually, I bet. Okay, 4. In a class of 40 students, 19 play tennis, 20 play netball, and 8 play neither of these sports. A student is randomly chosen from the class. Determine the probability that the student does one of these things here. Your best bet on this one here is to draw a Venn diagram and fill it all in, and then that makes all these questions here a lot simpler. So let's do that. Okay, so here's our Venn diagram. There's 40 total people that are going to be inside of this. We know that 19 play tennis. So we know that 19 are in these two regions together. 20 play netball. So there's 20 total in these two. And then we know that 8 don't play either. So that's the first thing we can start off with, is we know that there's 8 outside of here. Okay? So with the 8 outside of there, 40 minus 8 leaves us, there's 32 people that play tennis, netball, or both. Okay? Because now what a lot of people will do with this originally and say, they'll say 19 plus 20 plus 8 is more than 40. You're right, because there's some that play more than one. Okay? So if we've got 19 that play tennis and 20 that play netball, so we got 19 plus 20 gives us 39. So it's going to be 30, like if we were to put 19 here and 20 there, that means that we'd have 39 plus 8, we'd have too many people. So what we want to do here is do 39 minus 32, and that gives us that 7 of those people, we would be 7 people too many, so that means 7 people got counted twice. So that means this number here in the middle is going to be 7. Okay, and now that's what's going to make our life a lot easier once we figure out what that is. Okay, so we know that there's 7 that play both. So if there's 19 total that play tennis, we have 19 that play tennis. We already have counted 7 of those in the middle. So that means that there's only 12 of them play just tennis. And if there's 20 that play netball altogether, we have 7 that play also tennis. That means that there's 13 that only do netball. Okay? So now that we've got this Venn diagram filled in, now these questions up here should be a lot easier. So it says determine the probability that the student plays tennis. So that's the 12 plus 7, or the 19. So that's 19 out of 40 is going to be how many of them are going to play tennis, right? B, how many does not play, determine the probability that the student does not play netball. So there's 20 total that play netball. If there's 40 total, if we do 40 minus 20, there's 20 out of the total 40 that do not play netball, which is 1/2 is going to be our probability on that one. Okay. C, plays at least one of the sports. So that's these people all here. So it's all except for the 8. So if we did 40 minus 8, we would get that 32. Let's see, this is over 40 also. Let's be mathematically correct here. So 32 out of the 40 play at least one of the sports. So those are both divisible by 8, right? So that's going to be 4/5. Okay. And then let's see. Let's do D. Plays one and only one of the sports. So now that's going to be, there's 12 people that just play tennis, and there's 13 that play just netball. So that's going to be 12 plus 13 out of the 40. So that's 25 out of 40. Those are both divisible by 5. So that would be 5/8 of the people play only one of the sports. Okay. E, plays netball but not tennis. So here's our netball people, but they don't play tennis. So there's only 13 of those people. So 13 out of the 40 play netball but not tennis. Okay. And then F, plays tennis knowing that they play netball. So now this is kind of a little bit of a tricky one. Okay, so what we're doing now is saying, knowing that they play netball, that means we're only choosing the people that play netball. Okay, so we know that there's 20 total people that play netball. So for this problem here, we don't care about the 8 people. Well, we care about them, of course, but we're not counting the 8 people that don't play anything and the 12 people that only play tennis. We're only now looking from this group of people, the people that play netball. Okay, so knowing that they play netball, how many of those people also play tennis? So that would be your 7 out of 20. Okay, that'd be this one right in here. All right? Okay, let's take a look at the next problem, number 5. 50 married men were asked whether they give their wife flowers or chocolates for their last birthday. The results were 31 gave chocolates, 12 gave flowers, and 5 gave both chocolates and flowers. If one of the married men was chosen at random, determine the probability that he gave his wife, and then we get all these problems here. So, as you guessed it, it would be a wise idea to do a Venn diagram. So let's do that. Okay, so here can be our beautiful Venn diagram that I've made there. 31 total gave chocolates, so between these two spaces here, there's going to be 31 total. 12 gave flowers, and 5 gave both chocolates and flowers. So here we go. We've got 5 that gave both. Okay? If one of the married men was chosen at random to determine the probability. So let's see. We need to fill out the rest of these spaces in here, right? So if there's 12 total that gave flowers, we do 12 minus 5 means that there's 7 that gave just flowers, right? Because 7 of those 12 that gave flowers only gave flowers. 5 of them also gave chocolates. Okay, 31 gave chocolates. So if we do 31 minus 5, that means that there's 26 total that gave just chocolates. Okay, and let's see. We know that there's 50 total. So let's figure out here the deadbeat section. Deadbeats. That's going to be 50 minus these 3, right? Minus the 7 and 5 and 26. So that's 50 minus, let's see, 26, 31, 38. Right? So there are 12 deadbeats that didn't give them chocolates or flowers. Well, they don't necessarily aren't deadbeats. Hopefully they gave their wife something else nice. Okay? So now that we have that, find the probability that he gave his wife chocolates or flowers. So that would be all of these. That's the 38, right? So that's going to be 38 out of 50, which, let's see, that's going to, if we divide both of those by 2, that's 19 out of 25, right? Okay. B gave them chocolates but not flowers. So here's the chocolates circle, and then here's the chocolates and flowers. So there's 26 out of the 50 gave chocolates but not flowers, right? So that's 13 out of 25. Okay. C, neither chocolates nor flowers. That's the deadbeat category. Or deadbeats, we really should do deadbeats slash other. I want to believe that they did something else nice instead. So that's 12 out of 50, which is 6 over 25, right? And then D, what's the probability that he gave his wife flowers if it's known that he did not give her chocolates? So again, now we're not talking about all 50. We're talking about the people that didn't give them chocolates. So all of these people here, these 31, gave them chocolates. So now we're talking about just these 7 and 12, just the 19 people that did not give chocolates. So we know our denominator is now 19. How many of them did give flowers, knowing that they did not give her chocolates? So there's 7 out of those 19 gave her flowers. Okay? All right, moving on. Next one, number 7. From the Venn diagram, P, parentheses A, so remember the P stands for probability of A, is A plus B over A plus B plus C plus D. Okay, so what they're saying is the probability of A happening is things being in A. This is the stuff that's in A, that's A and B, and that's out of everything total in the box, which is A, B, C, and D. So that's why they have this here. So they're just trying to help you understand what the heck this diagram means. Okay, use the Venn diagram to find the probability of B. So probability of B are these two here, is the B and the C. So AI is going to be B plus C over A plus B plus C plus D. Okay, AII is going to be, what's the probability of A and B? So and means that they have to both happen, so that's going to be this middle section here. So that's just going to be B over A plus B plus C plus D. Right? Okay, and then let's see, AII is, or I should say A part 3. That'll make it easier. Probability of A or B. So now that can be A or B or both, right? So that's going to be A plus B plus C over A plus B plus C plus D. Okay, and some people will argue it's like, well, it says A or B. How do you, like, a lot of people want to argue that B wouldn't be included. They would tell you that. They would say A or B, but not both. Okay, but since it doesn't say that, A or B, you want to assume that that both is okay as well. Okay, and then A part 4 is the probability of A. It's got probability of A plus probability of B minus probability of A and B. So we got a bunch to do here. So probability of A, we know that that's this up here. So we've got A plus B over A plus B plus C plus D. Oops, D there. Plus the probability of B, which is B plus C over A plus B plus C plus D. Okay, minus the probability of A and B, which is A plus B plus C. So A plus B plus C all over A plus B plus C plus D. Okay, so we want to figure out what that all is there. So we've got, if we add those two together, it's A plus B plus B plus C. Right? But we're subtracting an A, B, and a C, so let's get rid of that A with that A, that B with that B, that C with that C, and because our denominators are all the same, so we end up with just B over A plus B plus C plus D, which you'll notice is the same as A and B. Okay? And that's actually what B is asking us. What's the connection between the probability of A or B and the probability of A plus B minus the probability of A and B? Okay, oh, oops, I think I messed this up. Oh, I did. Look at that. This one here, I did wrong, because that's the probability of A or B. I wanted A and B, so let's go back and fix that. I will just undo that until it all goes away nicely. Okay. So, back to this one, minus the probability of A and B. So that is A and B is just this B part here. So it's B over A plus B plus C plus D. Okay? So if we're subtracting the B away, so we can subtract one B away from that there, and we get this here. Sorry, so it's A plus B plus C, that's these three, all over A plus B plus C plus D. Okay? So then now part B, what's the connection between the probability of A or B, which is A, B, C, and D, and the probability of A plus the probability of B minus the probability of A and B. So they're the same, right? And the reason why they're the same is they're saying it's the probability of A plus the probability of B. We counted B twice, that's why we need to take that out, and that will be the probability of A or B. Okay? Okay. Last problem, number 8. In the Venn diagram, U is the set of all members of a gymnastics club. The members indicate their liking for apples, A, bananas, B, and oranges, O. There are 60 members in the club. Find the value of K. So we just got to add these all up, and we know that all of these plus K should equal 60, right? So let's figure that out. Okay, so we got 12 plus 3 plus 8 plus 7 plus 4 plus 14 plus 7, I believe. Isn't that it? 55. So plus a 5 more is going to be what K is. So find the value of K. K equals 5. So I'm going to scratch that K out there and put in 5. Okay. B part 1. If a randomly chosen member is asked about their preferences for this fruit, what's the probability that the member likes only bananas? So bananas is just this one here, just the only part. So there's 14 out of the 60. So that's 7 out of 30, right? Like only bananas. Okay. B part 2 is bananas and oranges. So how many like bananas and oranges? That's going to be this 4 and the 7, right? Because that's the overlap between bananas and oranges. So that's 7 plus 4 over 60, which gives us 11 out of 60 of them like bananas and oranges. Okay. B part 3 is how many like none of these fruit? That's the 7 right there. 7 out of 60. Right? Because that's those dudes. Part 4 is at least one of the fruits. So that's everyone except for those 7. So that really would be 60 minus 7 over 60, which is 53 over 60. Okay. Part 5. How many like all the fruits? That's just those 7 people in the middle of all of it. So that's 7 out of 60. Part 6 of B is apples and bananas, but not oranges. So here's apples and here's the apple and banana people, but there's the and oranges. So it's just those 8 out of the 60, right? Both of those are divisible by 4, so that's 2 out of 15. Okay, and then part 7 is oranges or bananas. So here's oranges or bananas. So that's going to be everybody in these 2 circles here, right? So that's going to be 8 plus 7 plus 14 plus 4 plus 3 plus 5 all over our 60. So let's see, that's 15, 29, 33, 36, 41. So it gives us 41 out of 60 like apples or bananas, oranges or bananas, and this is VII. So this is B part 8. Exactly one of the 3 varieties of fruit. So that's going to be this, this, and this, all those people. Because these people like just apples, those people like just bananas, and those people like just oranges. So we've got 12 plus 14 plus 5 all over 60. So that's, let's see, 12, 22, 26, 31 out of 60 total there. Okay. All right, that's all there is for 14J. If you have any questions about any of this, please feel free to ask in class. Thanks.